Hello everyone. Today I'm going to present my project topic, that is envisioning high demand areas in New York City for yellow taxi. In my presentation, I will be covering the following table of contents: introduction, business problem covered, the data analytics life cycle, how I manage the timeline, category covered, outcomes obtained, and how it can help the business grow, and the environment and tools. Moving to the introduction part, the TLC, that is Taxi and Limousine Commission, is an agency of New York City that regulates the taxi medallions. TLC mainly includes yellow taxis for hire vehicles and the green cabs. Yellow taxis is the most iconic among all of them, as it reserves the privilege to street haul passengers anywhere in the city, whereas for hire vehicles provides only pre-arrangement services and green taxi permits street hauling but is restricted to some zones of New York City. Moving on to the business problem statement. As we can see, the daily dispatch trips for yellow cab taxis is decreasing over the years. So the main problem statement that arises is that how to redistribute these taxis in New York City so that the demand of the taxi driver is met, and how many pickups are required in each zone of New York City can help the yellow cab taxi drivers prepare well ahead of time. So this is the following data analytics lifecycle that I followed for my project, and I will be explaining step by step how I move from the discovery to the operationalize phase. In the data discovery phase, I considered the following key activities. I drafted a business problem statement as stated earlier. I considered the problem to be an data analytics challenge. I accessed the resources available and needed, and I drafted an analytical plan. Looking at the current scenario, the yellow taxi company sends a particular number of taxis in Zone A, but in Zone A, the demand of the passengers is more and number of taxis is less. As a result, many passengers did not get the yellow taxi. There could be another scenario where the yellow taxi company sends more number of taxis in Zone A and the demand is less. So many taxis will be standing idle as a result of that. So what would be the desired situation in this case? The desired situation could be that the yellow taxi company could know well in advance how many taxis to send in a particular zone. For instance, in this case, the yellow taxi company sent approximately 3 taxis to zone A as the predicted pickups were 3, and as a result of that, the demand of the taxis were met, and the information is reloaded into the data science model, and again the prediction is carried out. I gathered the data using PySpark. First of all, I was using pandas data frame, but I was getting not enough memory error. So therefore I switched to PySpark, and these are the following commands that I used. And the Spark evaluates data frame lazily, which means computation happens only when the action appears. These are the data statistics of the data discovered. You can see that I divided the dataset into first and second half of 2018 and first and second half of 2019. You can see there are approximately 48 million in 2018 second half, 53 million in 2018 first half, 44 million 2019 first half, 39 million in 2019 second half, and I also gathered the weather data of 2018 and 2019. The zone data was in the form of a shapefile, and I used the Power BI to retrieve the zone centers as shown in the image, and on the right hand side is a zone map of the New York City. Now moving on to the data preparation phase. The key activities that I kept track of: I established the analytical sandbox using Google BigQuery, and it gives the ability to extract, transform, load, and retransform. I also performed data exploration, data conditioning, data wrangling, and removing outliers from the data and summarize and visualize the data. I also carried out visualization before cleaning. On the left hand side, you can see the histogram plot showing the distribution of a single variable, and you can see some negative amounts of the fair amount. And on the right hand side, there is a joint distribution plot that showcases the distribution between two variables. I also carried out some data exploration using BigQuery in order to find the outliers. I analyzed if there were rows with total trip amount less than 0 and the pickup date time is greater than drop off time, the rows with 0 or less passengers, and the trip where the trip duration is more than 12 hours, because the permitted duration is only 12 hours. There is a sample query that shows select star from the table where the pickup date time is greater than the drop off date time. A lot of data wrangling was also required to put the raw data into an appropriate format. It was done using BigQuery's and Pandas function. Below is a sample that shows I just converted label, time and zone ID into a pivot table and then unstack it in order to get a default bins for each zone ID. I also did some visualization after data wrangling in order to make sure that all the zone centroids are kept intact. Now coming to the modern planning phase, the key activities that I considered was variable selection and model selection. I also carried out data exploration in order to find the relationship between the variables. You can see the plots, how pickups changed day by day in 2019 and which zone ID was having the highest number of pickups and the average pickups per hour, and the correlation metrics were very helpful in order to study the relationship. After thorough exploration, I selected the following variables: zone ID, hour of the day of the week, day of the year, min and max temperature, and the rain. And apart from this, zone ID was a categorical variable, so it was handled using the technique of one hot encoding. After variable selection, I moved on to the feature engineering phase, in which I used one hot encoding to handle the categorical variables as shown below. I also used label encoding using BigQuery for the variables, and apart from this, I used the binning technique to divide the data set into particular bins so that it can be easily explored. Next, I moved on to the model selection phase. In the model selection, I researched and got to find out that I can use two of the methods in order to predict the number of passengers in a particular zone. I can use either the regression method or the time series. In regression, I use linear, XGBoost, random forest, or light GBM, and for time series, I stick to ARIMA. The fourth phase, that is the model building. I took care of the following key activities: train and test split with cross-validation. The cross-validation was done in order to avoid underfitting and overfitting of the data. I also used GridSys CV to select the best possible model. The metrics used to select the best possible model was MAE, MASE, and RMSE. This is the code sample showing the train and test split along with cross-validation. I did not use k-fold validation because it was taking large amount of time as the dataset was large. And I also performed grid search CV, where you can see I tested it for different parameters. For the time series data, I first of all I removed the seasonality and trend in the time series data, and I got the following as shown in the image. In the time series data, I also performed the Dickey-Fuller test in order to know whether the data is stationary or not. Before, I was getting a p-value of 0.35, which is greater than 0.05. So it was not stationary, but after removing the trend and seasonality, I got a stationary data. And then I forecasted the pickups and added back the seasonality and trend in the data to get the actual trips as shown on the right hand side. The following error measures were used in order to decide the model. Surprising to me, random forest regressor was the best among all the models that I tested with a MAE value of 11.57. So I decided to use random forest regressor. In the communication phase, I prepared some of the dashboards for the executive. I prepared some of the Jupyter notebooks for each of the phase that can be helpful for the analyst, and the model used by me was random forest regressor due to its least MAE and MASE as calculated by me. On the right hand side, there is a sample dashboard that showcases the trips in 2018 and 19. There is another dashboard that I prepared that showcases the weekly forecast demand in each and every zone of the New York City. So this will be helpful for the company in order to grow their revenue and to send the right number of taxis to the right location. So in my project, the yellow taxi driver can use my website in order to know the pickups, and the taxi and Lumison commission can take the help of the dashboards in order to visualize and forecast which areas require high taxi demand, and they can send that number of taxis at that location. Moving on to the operationalize phase, I built a fully functional Flask application and deployed my model on the Google Cloud App Engine. I use the Google Cloud App Engine, which offers platform as a service, and I also deployed my production server on the Google Cloud App Engine. My code and website link are provided as given below. Now coming to the operationalize phase, we can see that I can drag and drop the marker in any of the zone placed and select the date and time. For example, I want to forecast for the 7th of April at 12 a.m. and then press the predict button and now the prediction will go. The model will predict me and there are the number of pickups 416 at 12 o'clock in the night. So these are the pickups, and I have also scrapped the live temperature that the prediction day temperature will be the max will be 90 degree, the minimum will be 10 degree, and today's temperature is 16 degree and 8 degree in New York City. If you check the temperature today, that is 16 and 8 today, 16 and 8, so this curve, then 17 and 8, and here also 17 and 8, so the scrapper is working perfectly fine. This is how this work, and if you see the visualize forecast dashboard, it will open up the dashboard for you and you can easily view the result over here. So this is the operationalize phase that I'm interested in. You can easily see the high demanding zone, the time where the pickups are more, and which weekday has the highest pickup and which zone has the most demand. So this is how this all works. Okay. The following Gantt chart shows how I manage my timeline for the project, and I deployed my Flask application on 2nd of April. The outcomes obtained. The taxi driver will be entering the date and time and the location, and the web application will return the number of pickups the taxi driver can expect. There is also a live dashboard that will showcase the weekly forecasted pickups in each zone of New York City, and the live scrap temperature is also considered in predicting that forecasted pickups. The category of my project. I built a fully developed and operational cloud-based published website. Also, this website will help the NYC yellow taxi agencies to send the right number of taxis to correct location to meet the demand of the pickups at that location. I also scrapped live weather from Google for the demand prediction, and I was getting the not enough memory error, which I solved using PySpark. The business value of my application. The web app prepared by me can make it possible to redistribute the yellow cabs in the right areas at the right time. Each and every taxi driver can use this website to know the high demanding zones well in advance. The executive can use the dashboards to take effective decision. By law, there are 13,587 taxis in New York City, so the potential number of users are greater than 10,000. These are the environmental tools that I used: Google Cloud Platform, BigQuery, PySpark, and I made a Flask application. I also use Power BI, Data Studio, Plotly, Seaborn, and Matplotlib. I also use GitHub to host my code. That's all for my project. Thank you for listening.